This is test number 2, practice/review, question number 7a. We are asked to find dy dx by implicitly differentiating. We're given x cubed minus x times y squared plus y cubed equals 1. So I'm going to take the derivative of each side of this equation with respect to x. First, the left side. I get 3x squared times x prime minus, now we have two things being multiplied together. X is being multiplied by y squared. So we must do the product rule. The derivative of the first thing times y squared, leave the second thing alone, plus, leave the first thing alone, this x, times the derivative of y squared, plus. Now we'll take the derivative of y cubed. Well, that's 3y squared times, from the chain rule, y prime. And that's all equal to 1 take its derivative. Now we have the situation where the derivative of x from the step before is just 1. We're really multiplying by 1. Minus, that's this minus from up above. X, take its derivative, again, is just 1, so we're multiplying by 1. Then y squared plus, here we have x and x. The derivative of y squared is 2y times y prime, plus, now 3y squared times y prime. And the derivative of 1 is equal to 0. Now really the calculus is done at this point. Solving for dy dx or y prime, what we should do is get all of the y primes on one side and everything else on the other side. So I'm doing algebra. I move everything with a y prime by factoring out y prime in the last two terms. And I'm left with negative 2x plus 3y squared. This is this negative 2xy plus 3y squared. And I still had 3x squared minus y squared. So I subtract 3y squared over to this side of the equation. That's why you see the sign change to positive minus 3x squared, because I moved these terms to the right-hand side of the equation. Then I divided by negative 2xy plus 3y squared. For the final answer of y prime, which is the same as dy dx, is equal to y squared minus 3x squared divided by 3y squared minus 2xy.